hotel, for example, I claim my name to at the reception. I say my name is Thomas. In the digital world, I might provide a username, I might provide my email address, but that is not enough. I have to prove that I am who I claim to be. So that's what we call authentication. In the hotel example, I would provide, for example, my passport or my driving license, just to prove that I am who I claim I am. And in the digital world, we have different factors that we can use to do this authentication step. We can use a password, a token, we can use our biometric fingerprint on our smartphone, and hopefully we get a strong authentication system in place by combining multiple factors, what we call multi-factor authentication. For example, I can provide a password, but also a one-time code that I get through my application installed on my phone to generate these one-time password codes. After I know who is the user, and I'm sure that is actually that user calling my system, then I need to consider authorization. Authorization is all about verifying what the user is allowed to do. If I go to a hotel, I get perhaps a key or that can only open my room, the room that I booked and I paid for. I can't open all the doors for all the rooms in the hotel. In the same way, inside a software system, each user can only do certain pre-approved activities. And we define authorization in different ways. For example, we can define user roles, or we can define permissions and assign them to the user. So now that we have these three main steps for access control, let's move on and see what we can do for securing Java applications in terms of these three aspects. This will be the system that we're going to work on today. The example is the example of an online bookshop. A user, it could be an employee of the bookshop, or a user, a customer of the bookshop, access our system through what we call an edge service. So it works just like an API gateway. So it's the ingress point, the access point to our entire system. Then in the backend, we have a lot of different services with a specialized focus. We can have the inventory service, book service, order service, and more. In particular, we're going to focus on the book service, but everything we're going to cover regarding book service applies also to any other microservices that we might have downstream after going through the edge service. So in order to secure a system, since we are working with Java applications in this example, and in particular with Spring Boot applications, I can use the Spring Security module from the Spring ecosystem. Spring Security is the de facto standard for securing Spring applications. And in particular, the framework handles three different aspects of securing applications. The first one is authentication. We can implement authentication in different ways. Spring Security provides support for username and password-based authentication, for OpenID Connect and OAuth2. That's what we're gonna talk about today. SAML2. It handles authorization, and we can handle authorization at different levels, at the endpoint level, at the method level, or at the object level. And then finally, the philosophy of Spring Security is that when you add Spring Security to your project, the application should be secured by default. So besides having these features for dealing with access control in terms of authentication and authorization, we also get a lot of different protections against common exploits and common attacks than usually against web applications. For example, session fixation, cross-site request forgery, and content injection. And we're going to see a couple of those as well today. So we have our requirements in place. We want to implement an access control system for our bookshop application. We have different Java application services that we want to secure. We're going to use Spring Security. So let's start talking about authentication. That's the first step. First thing we want to do is knowing who is the user. So if we go back to the architecture of our system, we can see that we have the edge service that acts as an API gateway to the system. And since it's the entry point to the system, is also the perfect place to ask the user to authenticate themselves. So we can decide here if we want to implement the authentication mechanism within Edge service, or perhaps since security is such a critical concern nowadays, we might want to have a dedicated service that deals with authentication and have Edge service using this dedicated service to do the actual authentication step. So Edge service initiates the authentication step when the user sends a first request to our application, but then it delegates the actual authentication step to a dedicated service. And now we have a few different possibilities in regards to three main problems that we have to solve. The first problem is the strategy for the authentication. So how do we want to ask the user to authenticate themselves? Will it be through username and password? Will it be through a social login? For example, logging in through Google or GitHub, Twitter? We have to make a decision there. Next, we need to agree on a protocol. Since Edge service delegates an external service to do the authentication, how are these two services talking with each other? We need a protocol there. And finally, we need a data format to exchange information between these two services, because once the authentication step is done, we need to inform Edge service about who is the user. So we need a data format to deliver that information back to Edge service. And the solution that we're going to see today to solve all these three problems is OpenID Connect, which is a protocol built on top of OAuth2 that enables an application, and we call it a client, to verify the identity of a user based on the authentication performed by a trusted party. Now, this trusted party, we call it authorization server. So if we go back to our diagram, we have the Edge service that will act as an OAuth2 client, and Keycloak that will act as an OAuth2 authorization server. We are using the naming provided by the OAuth2 framework. And then, so we have the protocol, that's OpenID Connect. The strategy is free, meaning that since we have Keycloak now that deals with authentication, we can configure Keycloak to authenticate users in many different ways. So we can be flexible, provide multiple strategies. And the best part of that is that Edge service doesn't need to know how. Edge service only needs to know that a user has been successfully authenticated. The strategy doesn't matter. So regarding informing Edge service about the user that just authenticated with Keycloak, we use an ID token. An ID token is a JSON web token, so it follows the JWT format, and it conveys some basic information about the user. For example, if I'm Isabel, then it contains the name Isabel in the token as the subject of the token, when the token expires, and who issued the token. In this case, it's Keycloak. So let's have a look at the system now and do some live coding. So we'll start from the basic system without authentication. So I have the book service application. Let's run it. I can show it's a standard Spring Boot application where we have a record of, for defining the book data model, where we have the ISBN, which uniquely identifies a book, and the title. And then I have a REST controller to deal with books. For simplicity, now I'm using an in-memory map, but that's fine for the example. Of course, in the real world scenario, we would use a database. But the important part is that we have different endpoints to retrieve and create books. And right now, there's no security in place. So we have the data model and we have a REST controller that allows to retrieve the books and create new books, add them to the catalog. And then we have the Edge service. So the user will never interact with book service directly. We are going through a gateway. And this application, I can show you that it's using Spring Boot and a framework called Spring Cloud Gateway that is part of the Spring Cloud umbrella project. Spring Cloud Gateway implements an API gateway. So I have defined in the application property file a route so that every time I send a request starting with /books, then the request is forwarded to the book service that is running on port 8000 on my machine. So I'll start the application as well. Let's run Edge service, and then I can show you how it works. All right, we started. So if I open a browser window here, and I go to localhost 9000/books, then I get the list of books from book service. So our goal now is to, first of all, authenticate the user. So I don't want the user to access the books without being authenticated. We also have another endpoint, it's called welcome. This is provided by the Edge service itself. So we have the welcome endpoint provided by Edge service and the books endpoint provided by the book service. But both of them are accessed through the same service, through the same API gateway. All right. So let's start implementing authentication in Edge service. And I mentioned earlier that we're going to use Spring Security. And Spring Security provides a native support for using OAuth2 and OpenID Connect. So for future reference, I'd like to show you how you would initialize the project from the Spring Initializer at start.spring.io. You can add a dependency on Spring Security if you're in general working with the basic Spring Security features. But if you're working with OAuth2, then you can pick a dedicated dependency here that includes everything needed to work with OAuth2 and OpenID Connect. And since I'm working now on Edge service will have the client role in terms of OAuth2 and OpenID Connect. So I can choose the OAuth2 client library. That's all I need to turn Edge service into an OAuth2 client. So let's do that. I have the dependency here that I have to enable, like that. And like that. Okay, so I have the dependency now. The first thing I need to do is telling Spring where to find Keycloak, where to find the authorization server. And I can do it from here. So I have a configuration property that I can use, Spring Security OAuth2 client. And then I have a registration section and a provider section. Now in the registration section, I have to put the information about Edge service as is registered in Keycloak. I have done already, so let's have a look at how it works. I have Keycloak here running. All this security configuration is contained within what is called a security realm. The realm is called Polar Bookshop. And I have registered my application. Let me log in. I have registered my Edge service application so that it's authorized to use Keycloak to authenticate user via OpenID Connect. And the information that I have here is the name of the client ID, Edge service. I choose down here the authentication flow. I want the standard flow based on OpenID Connect. And also I have the credentials. So there is a client secret that I need to provide to Keycloak in order to authenticate Edge service. So let's do that. The client ID, it's Edge service. The client secret is super secret. It's Polar Keycloak secret. Don't do that in production. And then we have the provider. So the registration is for Keycloak. So let's add the key there. And then the provider section, we have to specify where Keycloak is running. So the issuer URI, I have Keycloak running on my local host, port 8080. And I want to work with the Polar Bookshop realm, like that. All right. So with this configuration now, my Edge service application will be able to initiate this authentication flow based on OpenID Connect and delegate Keycloak to do the actual authentication step. Then, besides that, I also want to make sure that my application is secure. All the endpoints require authentication, so I can go in my application code and add a new bin of type security web filter chain. So this is how we configure Spring Security. Spring Security works by going through a chain of filters. So every time an HTTP request comes to the application, before processing the request, Spring Security goes through all these filters. And one of the filters, for example, we can use it to authenticate the user. And in general, all filters can be configured via this bin of type security web filter chain. We have a Fluent API provided by an object called server HTTP security. And here I can define all the security policies that I need for my application. So I have them all in one place. And the first thing I want to do is making sure that all the requests, this is a reactive application, so requests are named exchanges. I want all exchanges to require authentication like this. So any request, doesn't matter what, should be authenticated. And then the type of authentication strategy is based on OAuth2 and OpenID Connect. I can configure this, and I'm fine with the default configuration. Like that. Now, if you work with Spring Security before, perhaps you've been defining these filter chains in a different way. Now, this is the new way to do configuration with Spring Security. In the past, you were required to extend an interface or implement a class. So you would have the same implementation within this method, but in a class extending a security filter chain adapter. Now that possibility has been removed from Spring Boot. So now the way that we can configure Spring Security is via a filter chain bin. This works both for imperative and reactive applications. All right. So to recap, I have registered my application in Keycloak. I have configured my Spring Boot application to use Spring Security OAuth2 and OpenID Connect support. And then I define the security policies that I want for my edge service application. All requests authenticated, and the authentication should happen via OAuth2 and OpenID Connect. So if I restart now edge service, and I'll just shut down. So let's run it from here. Yes. All right. So let's see what happens now. I open a new private window here in Firefox, and I go to localhost 9000/welcome. And now you can see that the Spring Boot, my Spring Boot application via Spring Security realizes that I'm not authenticated. So I'm redirected back to Keycloak. You can see I'm not on my application anymore. This is localhost 8080. That's Keycloak. So in Keycloak, I have different users that I can use for testing. One of them is Bjorn. So I can log in as Bjorn. And now I can finally see the data. That's the default behavior. I'm not authenticated. Spring redirects the browser to Keycloak. And from Keycloak, I can authenticate. So one last thing I'd like to point out here is that since I'm authenticating with Keycloak, Edge service will never know my credentials. So all the components in my system, except the authorization server, that is, in this case is Keycloak, will never know my credentials or any additional sensitive information about how I'm authenticating. I just get what is returned via the ID token. For example, my username or the list of roles and permissions that I have in the system. Nice. Now, authentication step, perfect, it's done. However, so far I've been focusing on one application only, Edge service, but we are working with a distributed system. Downstream, I have several applications like book service that I need to include in this security setup. So that's what we call delegated access, because now Edge service knows who is the user. The user is fully authenticated, but book service is not secure and doesn't know anything about the current user in the session. So we need to consider now this interaction between edge service and book service. In particular, one problem we need to solve is how can we securely propagate the context, the authentication context between edge service and book service. And the second thing that we need to solve is how can we ensure that we get from edge service authorized access to book service? Because book service is the application containing the data that the user wants to access. It's also what we call resource server. It provides the data that we want to access. So the user is actually asking edge service to get the books from book service on the user's behalf. And that's what the OAuth2 framework realizes or solves, because it's a framework that enables an application, again, we call it client, to obtain limited access to a protected resource provided by another application that we call resource server. And that happens on behalf of the user. Now, this framework actually was defined initially to solve a problem with delegating access to third-party applications. Now, think about using an application that lets you schedule tweets on your Twitter profile. So this application would need access to your Twitter account in order to post tweets on your behalf, but you don't want to share credentials with this third party. OAuth2 is a solution to that problem because you can delegate access without sharing credentials. But besides being very useful and solving a very critical issue that we have with third parties, we can also use it in our distributed system, in our microservices architecture. And that's what we're going to do. So we have edge service that is still our OAuth2 client, and then we can configure any application downstream as OAuth2 resource servers. And the way that we propagate the security context, and in particular, the way that edge service gets authorized access to book service, is via another token. This time we call it access token. So let's have a look at how we can solve this problem in practice. First of all, we need to make sure that book service is secured. So I can use Spring Security here, but this time I'm going to use a different dependency. Let me close that window. I have different dependencies stole from the Spring Security project, but this time is a starter dependency specialized to provide anything I need for an OAuth2 resource server. If you do this from start.spring.io, you can select the dedicated dependencies called OAuth2 resource server. That's it. So now that we have the dependency, let me reload the project. All right. Yes. I have to do two things. The first thing is informing book service where to find keycloak. So I'm going to do Spring Security OAuth2 resource server JWT and then issuer URI. Now, ID tokens are always JWTs, are always JSON Web Tokens. That's specified by the OpenID Connect standard. On the other hand, access tokens that are defined in the OAuth2 specification don't have a fixed format. So you can have different types of access tokens. That's why we have to be explicit about what type we are using. In this case, I'm still using JWT. So I'm explicitly configuring support for JWT. And then I can point to the same keycloak instance that I used earlier, port 8080 for Bookshop. All right, that was one step. The other step is now ensuring that book service is authenticating all the requests. I can use the same approach. Now, edge service is a reactive application. Book service is imperative, but you can see that the programming model in both cases is basically the same, because I have still a security filter chain that I have to define. I have an HTTP security object And then I can say HTTP and define the policies for this service. I want to authenticate all the requests. So for each request, I want to ensure that the user is authenticated. And then I want to use the authentication strategy based on access token. So with as an OAuth2 resource server. And then once again, I'm going to use default configuration for a JSON Web Token. And this will throw an exception. So you can see here, I want to show like this. So if I pick the other configuration class, just to showcase the difference between imperative and reactive, is the same programming model, but the interfaces are slightly different. So you can see that the reactive is called security web filter chain, while in imperative is called security filter chain. There's the difference between exchange and request, but it's the same approach both ways. So it's really straightforward to move between imperative and reactive applications. All right. So I'm gonna rerun the book service application now, so we can see that it's working correctly. Yes, but we haven't solved the problem of propagating the context from edge service to book service. So in order to do that, I need to go to the configuration properties for edge service. So let me close that window. Since I'm using Spring Cloud Gateway, I can propagate the access token . Yeah, I hope you can see my screen. There was some hiccup in the connection.
Yes, we can.
Okay, perfect. Thank you. Yes, so we have to put two filters in edge service. One is to relay the access token from edge service to book service. The other one is to make sure that we save the session data. And I'm going to explain what does that mean. But first, I want to show you the application working with this flow. So I'm going to run again edge service. All right, and then see if it's actually working. So let me check the sessions here. So you're probably wondering why I'm doing this. That will be clear in a few minutes. So I'm signing out from Keycloak explicitly, and then I can create a new window and go to my edge service /books. I'm not authenticated, so I'm redirected to Keycloak. I sign in, and now I can see the books. Now, it might seem that nothing changed compared to before, but now under the hood, what is happening is that edge service is calling book service in an authenticated way. So we have authentication all through from user to book service. The user authenticates with Keycloak, and edge service gets authorized to call book service on behalf of the user. And therefore, like, the user gets back the list of books. And I used Spring Security for OAuth2 client and OAuth2 resource server. Now, if I were working within this application with something like TimeLeaf, so providing a front end using server rendered pages, then I would probably be done with my security setup. But in my system, I want to use a single page application. I actually have an Angular application running that I want to use as the front end. And since I'm going to do that switch to a single page application, now it's based on Angular, but it's something that in general is true for any single page application, we have to configure a few extra things in Spring Security in order to make that work. So the first thing I'll do now is ensuring that via the gateway, I get access to this front-end application. So I'll create a new route. I have a front-end application running on Nginx. It's locally running on port 9004. And then for the predicates, I specify the root and all the CSS files, all the JavaScript files, and perhaps the icon. Okay. So if I restart the application now, we should be able to see the single page application when we access the root endpoint. Let's see if that's true. Once again, I'll sign out from Keycloak. So we start fresh. And then if I access now port 9000, I'm not logged in, so I have to authenticate first. And then I can see the front-end application. For example, I can browse the books. So we can do a few things here. So I can see the books, that works. I'm authenticated, works perfectly fine. What if I want to add a new book here? Let's see if that works. Perhaps the Lord of the Rings. Something is not working here. Let's see. So when I create a book, I get back a 403 response, forbidden. That looks a bit suspicious. Let's see if I can log out. Nope, I can't log out. But here I get additional information. So an expected CSRF token cannot be found. If you remember earlier, I said that Spring Security has this philosophy of ensuring that your application is secured by default. And one of the protections that are enabled by default is against cross-site request forgery. Now, you might be tempted at this point because there's a lot of tutorials online that teaches you to do that, and say CSRF, something like this, and then disable. Now, this is extremely bad because if this protection is enabled by default, there must be a reason why. Spring Security wants to make sure that our applications are secure with the minimum configuration from our side. So disabling CSRF here is really a bad option, because this protection is fundamental when we have browser-facing application, and Edge service is a browser-facing application. So instead of disabling cross-site request forgery, we can make sure that it works paired with Angular, because the problem is that the default protection works fine if you're using Timeleaf or a server-side rendered front end, but it doesn't work with single-page applications. And the reason why is that the way that the protection is enabled is through a token. It's called the cross-site request forgery token. And Angular doesn't support reading the token as an HTTP header, which is the default way of protecting a website against cross-site request forgery. So we have to configure something specific for single-page applications like Angular ones. And I can do that by defining a different token repository that is already provided by the application. So since Angular doesn't support reading this token from an HTTP header, we can ask Spring Security to provide it as a cookie. And that's what I'm doing here. This implementation of CSRF token repository is explicitly done for Angular. You can see in the documentation here on the class. Because of AngularJS and also the new Angular, expect to find this token in a cookie named XCSRF token. So it's convenient that we have the implementation out of the box. We have to enable it. Now, for imperative applications, that would be enough. For reactive applications, we have one additional thing that we need to do. we have to add this CSRF web filter. Now, the problem with the reactive implementation is that this token is not activated because of how reactive streams work. So we have to do it explicitly. Then all the source code is on GitHub. I pointed to the GitHub issue where you can read more about this issue. But for reactive applications, I need this filter in order to make it work. So if I refresh the page, and let's do this again. New private window. Let's open the application, log in. I can see the books, that's fine. Let's see if now I'm authorized to add a new book. All right, now it goes through. So that was because of this protection that is enabled by default against cross-site request forgery. So we need this little extra configuration to make it work when we work with single page applications. There's a second problem that is not visible right now, but the problem is when we have this authentication flow and redirect the browser to Keycloak. If I wait for 5 minutes, for example, my session will expire. So I would be redirected back to Keycloak to log in. But in doing that, I would get an error because of a course issue. So cross-origin request. Now, this is a very subtle problem that usually is not very clear because you don't get much information out of debugging from the browser. But if you think about single page applications, the way that we interact with the backend, for example, when I added the book, is via an AJAX request. Now, AJAX requests don't work well if I have a redirect flow to an application that has a different origin. So if from here, I try to use AJAX, and then I'm redirected to Keycloak on port 8080, that would mean that the origin, localhost 9000, is different from the Keycloak URL that is running on port 8080 and wouldn't work. So the solution to that is being explicit in how we trigger this login flow. Right now, it's automatically done. I access the application and not log in, and then Spring Security redirects me to Keycloak. What I want to do instead is having Spring returning a 401 response, and then I want Angular being in charge of when I start the authentication flow. And I can do that again in the security web filter chain. I can add no, not that. So we have the exception handling section here. And in particular, I want to configure a custom authentication entry point. That means that whenever I call the application and I'm not authenticated, status server entry point, what I want Spring to do is to return an unauthorized response. So 401. Right now it's returning 302 and it redirects me to Keycloak. I don't want that because it doesn't work with Angular. I want 401. So if I do this now, it's Angular in charge of redirecting me as a user to Keycloak whenever Spring returns a 401 code. That's good. One last thing, though, is the logout part. So you notice that now if I click on logout, it will work because I handle the CSRF protection in a way that works with Angular. However, even if I'm logged out of Spring, if I go and check in Keycloak, I have still an active session. And I don't want that. I want to be able to log out of Spring knowing that I'm also logged out of Keycloak. I don't want to keep this session alive. And that was the reason why I had to keep signing out explicitly. So I would like to do that automatically. So if I log out of Spring, then Spring propagate the logout request to Keycloak. The good news is that OpenID Connect has a protocol, has a solution exactly for doing that. And Spring Security supports that out of the box. We just have to enable that functionality. So the last change I'm going to do here is defining a logout success handler. And this logout success handler is executed whenever a logout operation concludes successfully. And what we want to do here is, after logging out successfully of Spring, then we want to also propagate the logout request to Keycloak. We have this implementation, client-initiated logout, that's based on this protocol from OIDC. And finally, we want Keycloak to redirect the user back to the homepage of the application. And instead of hard coding here localhost 9000, I can use this very convenient format. I just say base URL, and then Spring will automatically replace that with whatever is the host name and the URL used for the application. So if I deploy the application in different environments, then I don't have to worry about changing the value here in the code. So last step, I have to enable that. So I add now a logout policy to my filter chain, and logout, yes, logout success handler. We point to the one we have just defined. And then we need to pass this object, which is auto-configured by Spring Boot. So all I have to do now is inject it in here, and it will provide it for me. The client registration repository basically stores the information about the client registration. And in our case, is the information that I have defined here. This is the client registration data. We need that because when we ask Keycloak to log out the user, we need this data to authenticate with Keycloak. That's why I'm passing that object. All right. So the application now is restarted. Let's check that there's no pending session in Keycloak. Perfect. So I go to the application now, and I think there's some mistake. Let's see. So we have the security chain. Oh yeah, that's interesting. So now that we are returning 401, where we are not logged in, we expect Angular to do something about it. However, our policy enforces all requests to be authenticated. So we have to enable at least access to the single page application. So we have to update the policy. And in particular, I want that all requests matching the root, and once again, CSS files, JavaScript, and the icon. So if it's files from the Angular application, I want the request to be permitted. Any other request should be authenticated. If I don't do this, then I don't get the possibility to do the login, right? Because now it's not done automatically by Spring, but it's a responsibility on Angular. So I'll restart the application, refresh the page. Let's see with the new one, localhost 9000. I might have missed something. Let's double check. Oh yeah. All right. New try. Okay. Yeah, I misspelled the files there. So you can see now I'm not asked to log in, but I can decide when to log in by clicking on the login button. So I click there, and then I'm redirected to Keycloak. And I can do that without problems with the course, because I'm not doing this redirect through Ajax, but I'm doing that via standard HTTP through the browser. And that's something that I really need to make an Angular application work, or in general, a single page application. So I'm here. I can log out. Can you still see my screen?
Yes, we can.
Okay. Yeah, some hiccups again in the connection. Sorry about that. Yes, so let's start it over. So I'm restarting the Edge service application. I make sure that I have no session in here. All right. And now I am explicitly saying when I want to log in. Nice. So we have now handled also the authorization part, authorization in terms of having Edge service being authorized to access book service. We are using this access token that is propagated automatically when we have Edge service doing the delegation with Keycloak for the authentication step. We talked about the token relay process. So as you can see here, we have Edge service that has to store the mapping between the session cookie that is shared with the browser and the access token. And that's why we need that filter save session in Spring Cloud Gateway. We need to make sure that that token is saved in the session and associated with the session cookie that is exchanged in the browser. An important thing I want to highlight here is that the browser is never exposed to any tokens coming from Keycloak. We are doing all of this in the backend. And the reason is for that is to ensure the best security possible level that we can do with OAuth2 and OpenID Connect. Because I could also have the browser application like Angular initiating all of this and being in charge of getting tokens from Keycloak, but then we would have to somehow protect these tokens from the browser. And that's we can use different techniques, but they are never 100% secure because in the browser we can't hide the tokens in a very secure way like we could in the backend. That's why if you're working with web applications and you have the front end, I recommend, and this is a general recommendation when using OAuth2, the recommendation is to have a backend service in charge of handling all this flow. And then between the browser and the backend, we can exchange a session cookie as a traditional application. And then we talked about a few extra configurations that we need when we work with this single page applications. So going back to the 3 steps we mentioned earlier and the goal of having this access control system within our Java applications, we talked a lot about authentication. We talked about authorization from a service point of view, so that Edge service is authorized to access book service, but we haven't talked about authorization for users. So I'm not gonna deep dive into that, but I have a GitHub repository if you're interested, showing different examples on how you can use access tokens in order to convey the list of roles or permissions associated to a user. So if you're interested in that, I recommend you check that repository with different examples. And with that, I'm done for today. All these examples are on GitHub. And if you have any questions, I'll be happy to answer. I hope this was useful. Thanks a lot for joining. And once again, I'd like to thank the organizers for having me.
Okay, yeah. So Thomas, a fantastic session. Thanks a lot for doing this. Really interesting insights, especially around how Spring Security out of the box, helps you prevent CSRF and stuff like that. See a couple of questions. Some got forwarded to me, and some are on the chat. There's one from Benjamin, where he's saying, "Will you be in a position to share this code?" But I think you've already done that. And it's already on the slide. Benjamin, and yeah. I think the second you've already covered when you spoke about it, right? Are all Edge servers supposed to be reactive? That's the question. So
Spring Cloud Gateway is based on the reactive stack of Spring. So there are possibilities to do it in an imperative way. The problem with that is like the reason why has been chosen to implement Spring Cloud Gateway on top of reactive is because since it's at the very ingress point of our system here, we have a risk of Edge service becoming a bottleneck because we receive a lot of requests. So using reactive programming paradigm allows us to build more scalable and more resilient application. So it's really a good fit for an application like a gateway that sits in front of all the other services. So doing it in an imperative way, it would have performance implications. So the official implementation is based on reactive. I know there are some support, if you check the documentation of the project, also some tips on how you can implement the same thing on Tomcat or servlet-based application. However, it's not the recommended approach for this reason, because you risk to have big performance issues and resilience issues at the very entry point of your system, which is really risky to have, because if that component is not accessible, then the whole system is not accessible.
Got it. Great. Yeah. So that's great. And then there's another question from Samarth, and this is about how do we do a curl request to book service? Do they need to provide the JWT to the curl, or just the basic auth? With just the basic auth, you get redirected to the Keycloak.
Can you repeat the question?
Okay, yeah. So the question is, how can one do a curl request to book service? Do they need to provide the JWT to the curl, or the basic auth that gets redirected to Keycloak?
Yes. So
that's
I'm trying to share my screen again, so I can. Yeah, it's. I can show that. Okay, I think I'm sharing. So
yes.
When we call a book service directly, so with a curl, we have to provide the JWT token, the access token, as a header. So I have in the code, you can also see examples of tests. But if I take a CLI, so that might be clearer. So I have to provide the header authorization, and then the value of the header would be bearer, because it's a bearer token, and then you type the token here. So all requests going to book service needs to have this HTTP header. And the convenient thing when using Edge service is that that is done automatically for you. So you don't have to do it manually or explicitly, because Edge service gets the access token from Keycloak, and then it's always added in the HTTP header before forwarding the request to book service. If you need to call it directly, for example, if you want to test in isolation book service, there are different ways of doing that. In the code, you can find some examples of tests. I'm using test containers in order to have a test instance of Keycloak in here. So I can retrieve the access token from Keycloak as a first step. I'm using the Spring Web Client to send a request to Keycloak and get the token. And then whenever I call book service, you can see on this line that I'm adding that authorization bearer header with the token in the HTTP header. I hope I answered the question.
Yes, that's perfect. So and then another quick question that got forwarded to me is we have the OWASP top 10 security threats, right? So and then Spring Security obviously out of the box helps you avoid some of them.
Yes.
So one is obviously the CSRF. Any other things that it helps you do out of the box?
Yeah, so for that, I would really recommend checking the documentation. There's a section about all these like common attacks. They are also explained. So for example, if you want to have more information about what exactly is cross-site request forgery, or how does it work, then you can check that. Protection against exploits. So you can see in this section, for example, for CSRF, there's a whole page describing how you can perform the attack if you're curious. It provides a lot of different protections in terms of HTTP headers also, so you can go and check all the security headers that are applied by default in order to protect against malicious behavior, code injection, and a lot of different things there. So I think it's, yeah,
No, this is helpful.
I think it's worth reading the documentation because it's really, really well written, very informative. So you can find all the information there.
Perfect. Yeah, I mean, this is great. This is great. So I think, we're at the top of the hour. So, I would take this opportunity to sincerely convey my gratitude and appreciation, Thomas, for taking the time to do this really, really interesting session. There's a lot.
It was a pleasure.
Yeah. And, just to kind of let everyone on the webinar know, a recording of this webinar is going to be hosted on our Facebook page. And it's made available to people to watch it later. And we also encourage you to reach out to Thomas, should you have any questions on Twitter, and do check out the reference code on GitHub. Thanks once again, Thomas, and wish you a good day ahead.
You're welcome. Have a good day as well. Bye. Thank you.
Bye-bye.